Assalamualaikum warahmatullahi wabarakatuh and good afternoon everyone. My name is Nohelmi Birafi'i. My matrix number is 09DKM21F1051. Today me and my fellow group members who are Aaron Abishigam Peter 09DKM21F1006, Livendra Dev 09DKM21F1106 and Shaman 09DKM21F1121 will be presenting about the use of integrals and will be solving a question relating to it. First of all, integral definition. An integral is a function of which a given function is the derivative. Integration is basically used to find the areas of the two-dimensional region and computing volumes of three-dimensional objects. Therefore, finding the integral of a function with respect to x means finding the area to the x-axis from the curve. The integral is also called as antiderivative as it is the reverse process of differentiation.
I'm Shaman, and my matrix number is 09DKM21F121. Now I'm going to talk about applications of integrals. There are many applications of integrals, out of which some are mentioned below. In maths, to find the area between two curves, to find the area under a curve, and our average value of a curve. There's a 3 example given there, so you guys can refer to it. And for the second application of integrals in physics, there are some points, and one of it is center of gravity, mass and momentum of inertia of vehicles, mass and momentum of a tower, and the center of mass, a velocity of a satellite at time of placing in orbit, the trajectory of a satellite at the time of placing in orbit, and to calculate thrust. And there are some pictures are given there. Thank you.
Selamat sejahtera puan, saya Livendra Dev dari kelas DKM 2B dengan nombor matriks 09 DKM 21F1106, dan hari ini saya akan present untuk part solving soalan dia. So the question we took from page 203 and it's question number 4. Okay, based on the solving part above, you can see first we have to find the two intersection points between the curve and the straight line. To find the intersection points, I have used substitution. I substituted the straight lines equation into the curves equation, and then once I solved it, I got both the points for the y-axis, because the question is asking us to find from the y-axis the volume if it rotates around the y-axis. So I found 2 points of the y-axis. After then, I just used the formula of volume when a graph or a curve rotates around the axis, which is integrate the 2 points. Integrate the 2 points, which would be -2 and 1 pi x square dy. Then I just substituted the curve of the equation of the curve into the formula, which would be 5 minus y square, and then I square the thing, and then dy, and then I took out the pi outside. Right after that, I expanded the thing. I don't really like to use with a lot of power, so I just expanded the thing. Then I integrated it. After integrating it, I substituted the 1 inside, and then I substituted the -2 inside. Right after solving everything, at the end I got 2 values. Then I minus the 2 values and I times it with pi, and I got my final answer as 96.14 units. And for the curve, for the sketching of the graph, I found out the x-intercept and the y-intercept for the straight line. I also found out the x-intercept and the y-intercept for the graph, the curve, and I drew it accordingly to the points that I found. That would be the solving steps for this question. Thank you.
Hello, my name is Aaron Abishigam Peter, matrix number 09DKM21F1006. Today I'll be finishing our presentation today by explaining the conclusion of our presentation, which is applications of integrals. So, in conclusion, with integration and differentiation as mathematical strategies, I had been capable of attaining the answer to the distinctive strategies used. So each of the strategies brings an easy and clean manner and consequently may be used for real facts. Furthermore, with tables and figures, I had been able to cabin a position and examine the real facts with the anticipated facts. With both these facts, I am able to actually get data from it by using the integral way of finding an answer. So the reading of the distinctive international locations, which might be much less advanced, as given a top level view of the way overpopulation will motivate extreme troubles as an instance of instability, displaying the country's improvement, the vicious poverty circle and pollutants, and also environmental degradation, which is also like pollutions and all kind of stuff that normally human being does in the world. So, using the strategies above, I have been capable of expecting populous sizes with and without my own circle of relative making plans. For instance, I analyzed my own circle of relatives making plans coverage in China and evaluated the way it has advantageously helped China in its improvement and poverty reduction. So in these ways, we can take as an example from China and implement it in Malaysia as well to reduce the amount of poverty that is in Malaysia, as we can see. So therefore, it is going to be real if I say that different growing and underdeveloped international locations need to emphasize the implementation of the own circle of relatives making plans rule that allows you to lessen the bad effects of the huge populace that has affected our international places. So this challenge can consequently be regarded as a systematic attempt to degree and manipulate populace increase within inside the contemporary international setup. Sorry for my stucking there. So it also can exist suffering or growing international locations undertake a number of techniques displayed above to enhance their social and monetary status. So that is all from me for our conclusion of today's presentation. So I hope you all understood whatever we presented today, and thank you.